thank everyone that is attending today to, actually this is the first ARISS press conference we've had. And I thank you for your interest and long-time support in the ARISS program. The way we're going to handle this meeting, just so everybody is aware, since this is a press conference, is that at the very beginning of this, there will be a presentation by myself and Oliver Amen, and then we would ask that we're going to try to keep everyone muted as much as possible, and as part of this, we will have a question and answer session. So if you have specific questions you want to ask, it would be best to put them in the chat. One of our colleagues will be monitoring the chat and will keep us informed. And that'll be John Clute, our Director of Operations in ARISS USA, as well as the International Operations Chair. So I did want to recognize several individuals as we get started here. Oliver as the International Vice Chair for ARISS. Kenneth Ransom, a lot of you know him from an operations perspective. Lou McFadden, who has been instrumental in the development of the Columbus Module Next Generation Radio System. John Clute, as I mentioned at this point, who's our, as I said, our International Chair for Operations. And so with that, Oliver, you can speak, is that correct? Just making sure you're...
Yes, I have the mic, and I will also share shortly my video, but then I will take it back until I'm on the presenting.
Yeah, and I will do the same. When you and I talk, we'll switch off the video on and off. So are we loud and clear, folks? I'll ask John that question.
Your audio is just fine, and just as a reminder, everyone, recording has started.
Thank you, John. Yeah, so if you don't want to be recorded, you might want to drop off, but most of you won't be recorded. It'll be us. All right, so this press conference is specifically to talk about the Columbus Module Radio System, our next generation radio system we have in Columbus Module. And there's been a lot of questions that have come up over the past few weeks as we've been working with the space agencies to debug the anomaly that we have seen. And a lot of people are asking a lot of questions, so we felt it was best to just have a press conference, talk about it, give people the opportunity to ask questions, and then move forward. So let's see if I can get this thing to work. All right, there we go. All right, so for 95% of who I think is on this teleconference, I don't think we need to say much about what this program's about. You know, one of the big things we're known for is letting students talk to the astronauts, and as part of that, giving them that once in a lifetime opportunity to do that through amateur radio, but also to spend about 4 to 6 months with them in a whole STEAM education, science, technology, engineering, arts, and math program to get them to learn about space exploration, space research, and radio science and technologies using amateur radio. And then our other important piece, and you'll see this in a minute here, is that we provide backup comm for the International Space Station. This is something we have been doing even on the shuttle program and Mir, very important for Mir in particular. And we are continuing that legacy and doing what amateur radio does, which provides communications when all else fails. So I wanted to show this chart more to talk about, you all know about the things we do from an education perspective with students, the contacts we do, you know, 60 to 80 contacts a week with students. But there's another important piece of our program, and those contacts, if there's, you know, 60, 80 contacts a year, I should say, that's about, you know, 1 to 2 a week. But the other 24 hours, 7 days a week activity, we have a lot of other capabilities here that we're using. We built this next generation radio system to actually provide more opportunities for education for students, as well as for the ham radio community. So, you know, being able to do voice repeater when the crew's not using the radio system is an important piece. Another is the slow scan television events we've been doing, the ham television, and then, you know, APRS. So digital, video, picture, voice, you know, we're trying to utilize those for the ham radio community, for those that are the do-it-yourselfers, try to get them interested in our hobby, but also to provide this as a lifelong learning platform for all and students, you know, to provide a more in-depth student capability than what we have today. So this is an important piece of information, and this basically shows the 3 areas that the ARISS radio systems have been in throughout the years, starting with the FGB and then going into the service module and the Columbus module. So right now we're using the Columbus module and service modules as our radio stations for this system. And I bring this up because first up at the top, you can see the new interoperable radio system in Columbus, but also to say that we built this system internationally. You know, there's an international team that's listening to this too, as well as participating from a volunteer perspective. We built this to be diverse and in different areas to support backup communication in case something goes wrong, but also to be resilient to issues that come up. And I bring this up because with our Columbus module radio down right now, which is the crux of what we're going to talk about today, we are still being able to operate and do our school contacts, at least in the service module. And we thank Sergey Sambarov for making that happen. So basically we were down for a couple of weeks while we got that set up, and Sergey's been working with us to ensure that all of the astronauts that want to use the radio can use it and have been properly trained. And actually, Victor Glover, we spent a little bit of time working with Sergey, the cosmonauts, to get him familiarization training in the service module, because he didn't have that beforehand, and that's been done. At this point, like I said, within a couple of weeks, we were operational totally again for doing school contacts. Now, what we can't do are some of the other things we were planning on doing in Columbus, and in particular, those of you that are very familiar with this, the voice repeater and the APRS activities. So before we go any further, a shout out to our sponsors in the US. It's NASA SCAN and the ISS National Laboratory provide support to the program, both in kind as well as real money support to the program. The same is true with AMSAT and ARRL within the United States, and we thank them. And then also, this is a time to really thank our ARISS volunteer team that put in so much work to make this program happen and be as successful as it is, and really make a difference to the amateur radio community, to the amateur radio community's future, as well as to the future of STEM activities, basically inspiring, engaging, and educating our next generation of explorers. So let's talk specifics about what's going on here. But before I talk, me and Oliver talk about the radio system and the issues, we need to kind of give you an overview of something that that many of us have been working in the background since actually 2016. And that's about the time when ESA and Airbus decided they wanted to build this commercial payload hosting platform called BARTOLOMEO. And there's a picture at the top right which shows if BARTOLOMEO is fully populated, all of the science and engineering activities that can be done with BARTOLOMEO. It was actually launched with the interoperable radio system on SpaceX 19 and on March 6, 2020. They were in the trunk of the SpaceX Dragon vehicle. We of course were inside the vehicle, a soft stow. NASA, ESA mechanically installed Columbus using the Canadian arm, the remote manipulator arm on January 27th. I'm sorry, before January 27th, almost immediately after it was docked to the International Space Station. But on the January 27th, we did an NASA did an EVA to take the hardware system on Bartolomeo and install all of the harnesses for the avionics, the antennas and things like that. So during the EVA, you're going to hear this PAPOS connector discussion. That's really what they're trying to do, is to install all of the harnesses and connectors to the Columbus so that they can fully utilize the hosting platform of Bartolomeo. Now, as part of that EVA that they did on the 27th of January, they also installed a cable, and I'll show this in just a minute, called HMU 601. This EVA cable, through the EVA, this cable was installed in series with our coax cable for our ARISS antenna. And the antenna coax cable is an HMU 895. We'll show all of this in just a minute. The reason this was installed was that in the bulkhead connector for Columbus, there's 4 RF feed-throughs on that bulkhead connector. At the time, we were using 2, and as Lou McFadden knows, because he built the 2 antennas, one of the antennas was for ARISS, another one was for AIS. And so what Bartolomeo wanted to do was, and AIS was going away, but ARISS was not. So what Bartolomeo wanted to do, or ESA Airbus, I should say, was they wanted to employ the other 3 RF feed-through cables, feed-throughs, so that they could cable them into the cabin and then have antennas on the outside for, basically future payloads that might want to transmit or receive RF signals. So that is the crux of what was happening on Bartolomeo, and I'll let you see here relative to the anomaly. What ended up happening was that after that January 27th EVA, when they installed that cable, the HMU 601, in series with our cable, the radio system was down. First thing that we asked the crew to do was to turn on the radio system. It came on in voice repeater. We heard no downlinks. With that going on, knowing that we had a school contact coming up in a few hours, we talked to the control operators, and I got the crew to switch us over to PM3, which is our APRS packet mode. We heard no downlinks by the ground stations there, and we heard nothing, we saw nothing on ARISS.net. And then we didn't want to stop the train, if you will, so we went forward with the contact in Wyoming, and that was a multi-point telebridge through ON4 ISS Jan, which is, he's got a phenomenal ground station. He heard nothing. He transmitted through about half the pass, and at that point we got word directly from the crew that they had no joy. They weren't hearing anything. So we basically shut down the contact and recognized that we had a radio anomaly. Whatever, basically there was a problem. So this is a question we're getting from a lot of people. What's all these cables you're talking about? And so if you'll look carefully, let me start over on the side here where the antenna is. And the first cable, which was installed back in 2009 with the antenna, is an HMU 895. That's a 16-meter cable that was connected. This EVA connector was connected right into this APCU area. Okay, and this is you'll see this. Oliver will show some of the pictures in just a couple minutes. But this basically goes to the bulkhead. Here's the feed through, bulkhead right here into the cabin to our interoperable radio system on the left-hand side here. Okay, and you can also see this is a pretty comprehensive diagram because it also shows our two L-band, S-band antennas that are on the side of the Columbus and how they're all wired in. Okay. So what happened during the EVA is that they basically disconnected this HMU 895 from this APCU and in series put the HMU 601 in. So what does that do? That feeds the RF signals into our, it's theoretically feeds the RF signals into our radio, and at the same time there's 3 other cables for Bartolomeo to be able to do basically 4, as you can see here, internal, 4 different cables with end connectors on them to be able to do different RF operations. So now this is the same chart, but highlighted here is 2 areas where we've been doing investigations associated with this of the anomaly. Okay, one of them, of course, is HMU 601. The other is HMU 898, which is the internal cable. Now, if you kind of read some of the emails we've sent out, there was a different cable. This says Mark II at the bottom of HMU 898. There was the original cable that had 2 connectors on it to support ARISS and AIS. That's still in Columbus module, but stowed away. As part of the debugging, we pulled this, and this is the system that was going to be used for Bartolomeo, just to validate that several things, and we'll talk about them in a couple minutes. But bottom line is that the 2 areas we've been focusing on in troubleshooting have been in the HMU 601 and the HMU 898 cables. So now I think I'm going to turn it over to Oliver, and you can walk through the rest of these charts, Oliver.
Yeah, thanks, Frank. If you could go back 1 slide, please, because I just figured out a typo that I made. I apologize. For clarification, the HMU 601 cable, where the pointer just has been, is not 8 meters long, it is 80 centimeters long. So there is the commutator in the wrong position. So it is an 80 centimeter stub only, which is very short. So I will correct this later. So as you can see, we are working very closely with these things. And what I want to present you now are some photos from the Columbus module. On the left side of this slide, you can see the Canada arm, which is close to the Columbus module. It is this folded structure with a specific holder on it. And the Canada arm can not only grab things and position things, it has also cameras on it. And we will show later some of these pictures. So we receive not only pictures from the cupola module or by the EVA of the astronauts, there is also a mean to make offline photos without crew. That means using the Canadarm. On what you can see, the orientation is that we are looking from the bottom side to the Columbus module. Bottom side means it is that side which is faced towards the Earth. We name it nadir side. On the right side, you can see the antenna. And the ARISS antenna is mounted to a handrail. And this is on these meteorite debris protection shields, which are covering the Columbus module. On the right side, the structure is the fixation for the Columbus external payloads. This has been mounted within the launch. And the experiment is, for example, on the right side where the cursor just points to, is the HDEF experiment. HDEF is used for these NASA TV pictures that you can see when they are showing the view to Columbus or towards Earth when they are crossing over the Earth. On the next slide, we will have a view from the top to the Columbus module. For your orientation, we just had a look from the bottom. Now we are looking from the top to this Columbus module, and we are looking into flight direction. That means in front of us there is the Earth, and it is the direction of flight. What you can see on the module are handrails. These are these yellow bars which are appearing. We will see them later on at much closer. On the left side, you can see that the Columbus module is attached to the ISS to the node number 2. It is the module which is on the left side connected to the GEM module, and where the Dragon capsule currently is docked to the front. What you can see on the left picture is the HMU 895 routing path. For the specialist, this is the routing of the cable prior to the EVA activity. That means it shows the old routing of the cable or the current routing of the cable and its fixations to the handrails, and as how it has been connected directly to the Columbus module to the APCU bracket. For your orientation on the right side, you can see this again, and the routing of the cable is that they are following the handrails to the starboard cone, and then they are rotating with the rounded cylinder of the Columbus towards the front side, and then they are going to the antenna. On this slide number 12, you can see the antenna in the lower left area, and this gives you an impression of the current situation, because in front of the node 2, you can see in the background the Dragon Resilience, the capsule, which is docked. And between the, or in front of the Dragon capsule, you can see part of the Bartolomeo platform already. So this is the view of the outside towards Columbus. The next point is that we will show you a little bit a picture out of the EVA preparations. In the front side, you can see a rounded area, which is the docking to the node number 2. We are looking now from the ISS structure towards Columbus. Left-hand side is flight direction and the Dragon capsule. What you can see on the left side of the Columbus module is the Bartolomeo platform, and a little bit below, because it's closer to the node 2, it is the Columbus Ka-band antenna, which has also been mounted recently. On the top, you can see a lot of numbers. These are indicating the numbers of the handrails. Such numbers are printed also on the handrails, and these serves for the astronauts for orientation, but it also serves for the integrators to giving advices how to fix something, to route something. And on this picture, you can see the routing of the antenna cable, and the HMU 601, the new cable from Bartolomeo, has taken the same routing path as via the 933, 910, 98, 96 towards the APCU bracket. The APCU bracket is close to the handrail 915. On the lower right side, you can see the HMU 601 cable being attached to the bracket, to the APCU bracket. And on the top, you can see the HMU 601 J02. It is the jacket where the antenna, the old ARISS antenna cable, has to be plugged in. So this gives you an impression of these 80 centimeters that I just mentioned of this cable adapter. So we are now coming to the slide number 14. And as you just have seen, the Bartolomeo platform is in front of the Columbus module. And here you can see a picture of the assembly as it has been launched. You must imagine that everything has to be handled. It has to be fixed for launch. And the green marked cable is the cable which is the P02 and the 601J02 cable which is now mounted to the APCU bracket and for the ARISS cable. So these are these 80 centimeter cables, but around of it, you can see the big, serpent of the big anaconda of cable, which is serving to host the 3 other RF cables, which are going from the BARTOLOMEO platform to the APCU bracket as well. So next slide. This is a close-up picture, which is very important for us for the determination of the situation. This is a photo after the EVA, which shows the interconnection of the J02 APCU bracket. We see a connector being plugged in, and we see below in the middle lower part of the photo, we can see another plug, which contains the ARISS cable plugged into these 80 centimeters extension cable for the HMU 601. So this shows that the interconnection has been done, but it also shows us a very interesting detail for us. These connectors are very special zero gravity lever operated connectors, NZGL connectors. And the position of these levers towards the lower part indicates us that they are fully engaged. That means that they are fully mounted, which is a very positive reading. And internally, the connectors are moved, and this shows that they are really fully inserted. This is as expected, this is good. So when looking to this picture, we would not assume that this interconnection can have any problems. So this is also the section which crew will touch next Saturday in the next EVA, when we will reinstall the old antenna cable.
Yeah,
So go.
Oliver, I think it's important before we move on to say that this cable here was originally here before the EVA, and basically this was plugged in during the EVA and this was connected here during the EVA. Correct?
Yep. Thanks, Frank.
So what that means too is that if we go back to the old way it was, is they would disconnect here, take this cable and connect it in here, and we would be back to the way we were before. So I wanted to, before we go any further, I wanted to bring that up. All right.
Yeah. And what you can see also on this picture is how these cables are fixed in orbit. Only for your curiosity, they are fixed by wire ties. You can see these wires here. So it's not Velcro or something else. These are fixed by wires. Yeah, on the next photo, we will take a look into such a connector. And this is now the view into the HMU 601 cable, but it is the site where the ARISS antenna currently is connected to. What you can see is that it contains, that one connector contains eight RF connectors, coaxial connectors. And when you are looking a little bit closer to the red marked arrow, this is the pin number 8, delta. And the pin number delta contains the pin or the interconnection towards the HMU 895 to our ARISS cable. When you are looking much closer, and I apologize that the detail is not that good, this is the only connector, this RF connector is the only one which has an insert inside. So when you are looking much closer in a much better resolution, you can see that it's shining golden. All the others are not connected internally. That means they are only providing the outer shield, but not an inner pin. So this has been inspected on ground, and the photo that you can see here is has been taken within the ground inspection on prior launch. So it's a part of the photo documentation. So this closes a little bit the photos that we had, which served us for our investigation, and I hand back to Frank.
Okay, thank you, Oliver. So as part of this, we looked at all of the potential areas where a failure could occur as part of our anomaly investigation. and a lot of them are not probable, but these were the three probable ones. Either the HMU 898 cable located in this inside the cabin had a cable break, because back many years ago there was a tight turn, and you'll see it in a few minutes, that potentially could have been a break in the cable. Another is you just saw that HMU 601 connector with the 8 opportunities that are part of that cable. Another potential cause could be the incorrect clocking of that connector. In other words, D might not be lined up correctly for one reason or another with the whole all the way through the system. The other is there an installation anomaly or workmanship issue associated with HMU 601? So those are the ones we were looking at, and that's where we started a lot of our troubleshooting. So here is that cable we were just talking about, and I'll say if you're a ham and you see this on the back of your radio, you would be a little concerned about it. So the first thing we did was we replaced this cable, this HMU 898, with that Mark II version. And this is the Mark II cable. You heard there's 4 connectors on the one side for each one of the 4 RF systems that would use it. P01, which this one here is for the ARISS system, and then the other 3 were for 3 other systems for BARTOLOMEO. And this is where the bulkhead. Oh, let me go back again. This goes into the side of the Columbus module, and you can see that right here. So here's J02 right here, installation. Okay. So here's some of the near-term troubleshooting we did. First, relative to the cable break, we replaced the cable with the Mark II version of the cable. We turned on the radio. We didn't, and we had it in P01, which is the connection that should be for ARISS. Using packet, we didn't hear anything. So we don't think this was a credible cause. Then we went into incorrect clocking of the connectors within the HMU 601. ESA and Airbus really wanted us to do this before the EVA that was going to happen on Friday last week. So we've tested all 4 of those end connectors with our radio system, and we did not hear anything. And then, so that's on the one side of the HMU 601. The other side, which is the side you saw, can't be fixed. It would require a replacement. In other words, what I'm getting at is if it was incorrectly clocked, nothing would go to our antenna. Okay, so the P02 is closest to the radio, J01 is closest to the antenna. So HMU 601 installation anomaly or workmanship issue, or this clocking that could be beyond what could be accomplished, which actually goes back to number 3, is really what we think the issue is. So the other thing that NASA did was they did that cable inspection, and some of the pictures you just saw using the Canadian arm, those high definition pictures came out of that. They showed that the EVA connections were nominal. So we think the likely cause of this is in the HMU 601 cable. So that's where we are right now. We've talked to NASA, we've talked to ESA, we've talked to Airbus. They're all agreeable for us to remove the HMU 601 cable, the one that's in line with our feed line path, and reinstall HMU 895 back to the APCU connector. So basically what we're going to go back to is what we had before the January 27th EVA. And then, we'll work with ESA and Airbus on any kind of way forward with troubleshooting the HMU 601. We would like to get that fixed too, frankly. And I think everyone knows this, but there was a contingency task added to the March 5th EVA, but the whole EVA was shortened. And so none of the Bartolomeo tasks were performed. And so now we were pleasantly surprised, because we thought we'd have to wait months. We're pleasantly surprised that an EVA scheduled for this Saturday. It'll include the Bartolomeo cable, Papos cable work, as well as the ARISS recommended antenna reconnect. And this is what's going to happen for those that want to track this. Friday, March 12th, they're just going to double check that both radio systems and the Columbus module and service module are powered off. That's a requirement for EVA, that we're off. And then the crew will start their EVA around noon UTC and come back in around 1800. Victor Glover and Mike Hopkins are going to be doing the EVA. Hopkins will actually be doing the Bartolomeo tasks. They'll start around 1500 UTC plus or minus 30 minutes. And the first thing they're going to do, the first thing Hopkins is going to do is work on the Papos interface. And then it'll take about 10 minutes or less to do the reconnect of ARISS. And then the next day, on Sunday, we expect to be reconnected using the P01 cable and powered back up in the packet mode. So around 12 UTC is when we hopefully will see the radio back in operation. Oliver, you want to cover this one?
Yes, thanks. Yeah, the chat is working, and thanks for your comments in the chat. Yeah, what we are facing are also European missions in the next months. And what we have to have in mind is that we will have 3 European astronauts in a sequence parallel to all these USOS and Russian cosmonauts and astronauts. We will have the Thomas Pesquet mission from the French Thomas Pesquet. We will have the Matthias Maurer mission from the German side, and the Italian Samantha Cristoforetti mission. And as you can see from the dates, they are overlapping. That means from beginning of or from mid of March 2021 until July 22, we will have astronauts, European astronauts on board. You should have in mind that the Columbus module is a European module, and we had a lot of school application terms already running. And currently, the school application period for Samantha Cristoforetti is working until end of March. That means we have already selected a lot of schools for Thomas Pesquet and Matthias Maurer at about 15 to 20 schools per period. And therefore, we have a high pressure that these crew calls at these school contacts can happen. We should have in mind that if we cannot use the Columbus module, we are depending on the module, on the Vesta module, as Frank explained at the beginning. And that means that we need to coordinate the school contacts a little bit more intensive with the Russian partners. So getting back the ability to have the Columbus module radio working will offer us a lot of more flexibility, and will also provide us with a better support for the European astronauts. Yeah, Frank, and we are coming to your slide.
Yeah, before I go to that, I want to bring up one other thing, and that's you saw all the potential anomaly causes, if you will. There are a couple others that are out there, and I wanted to bring them up at this point. One is, and I think we were planning on talking about this anyhow. One of them is some of you have brought up is there a problem with the radio? What we can tell you right now is that from all indications, the radio appears to be working as expected. You know, the radio was working fine before the EVA on the 27th of January. We did check, and I think Graham asked this question. We did check with Kenwood about utilizing the system We are operating it at a very low, the packet mode is very low power. They didn't have any problem with us doing that on an occasional basis. We only ran it for a couple of orbits for each one of those four opportunities. It was very clear that once you go over the mainland of one of the big continents, you're going to see something. And we had our ground stations prepared to look, as well as we were looking very carefully at the at ARISS.net. So there was nothing there. There is always still that possibility that there might be a problem with the radio. If this EVA is successful, if they change out the antenna and we still have a problem, there's two things we need to look into. One is the radio, and the other is the 895 connector. I mean the 895 cable. There's always the other issue with the 895 cable that by doing this EVA, the EVAs, I should say, that the bend of the coax might be too much, and we could break the cable as part of that process. So those are, in our mind, if we still have a problem after this, those are the other two items that we will be looking into. But at this point, and given the time frame, we couldn't get into those before this EVA was going to occur. So with that, let me see if there are other questions that need to be answered here, because I think we answered a bunch with what I just described. Oh, let me finish.
Yeah, there was one question about other RF measurement equipment on board.
Yes. Okay, we'll talk about that. All right, so before we get into those, I do want to say ESA, NASA, and Airbus have been phenomenal working with us on this anomaly. We recognize this is not our cable. Everybody needs to understand that. This is not our cable, but we're in this together as a team. We can't fly on space station without these folks. And you know, they are genuinely interested in us, you know, continuing our efforts. So they've been very supportive. The fact that, you know, within a week, they've turned around and we're going to do this EVA on Saturday is a tremendous positive. And as I mentioned, the second thing was a big kudos to Sergei Sambarov for allowing us to continue our operations in the service module. We talked to him, you know, just yesterday, and the beauty of ARISS is the tremendous closeness and teamwork that exists within our organization from an international perspective. This is how we are successful, and despite issues that will come up along the way. And so Sergei's been really good about that. And NASA, ESA, and Airbus have been too. So did want to bring that up. So Oliver, what were you saying one of the other ones was?
Yeah, one of the questions was about availability of RF equipment to measure something on board.
Yeah. All right. So the other thing we brought up long term was that if you had a TDR, a time domain reflectometer, or spectrum analyzer or network analyzer, you could actually determine where the breaks are in these cables and compare them to the drawings to see where the issue resides. I will say that we were trying to work that. There's some old equipment on the Russian segment we were trying to utilize, and ESA and Airbus were looking for some other items that are on board. That kind of got overcome by events in that, you know, we've got this EVA this weekend, and we're going to try to get the radio system operational again. But there is going to need to be some debugging to try to resolve these issues long term. Another person was asking about the 3 RF capable system and how this impacts Bartolomeo. Right now, they don't have a customer. You know, they're just building up their customer base for Bartolomeo. So they don't have customers for those 3 RF feed-throughs right now. So they were okay with us getting ourselves operational back in operation while they go back and try to understand, you know, what's going on with this system. And, you know, they're working on this PAPOS thing too. So that's another thing that they're in the middle of. So you know, we'll see how that all plays out. I'm sure they'll be engaging with us. Other questions?
Yeah, there was a question by Eric also if we cannot do any tests on orbit using the second radio directly.
So,
And to figure out if the IORS is faulty.
yeah, so that's one thing we were pursuing, was maybe turning on the radio in the Russian segment and trying to see if we could hear on either side. The problem with that is with no antenna, if you will, in Columbus, we're not sure how that would work and what kind of information we would gather. So given that each one of these things are going to take crew time, we did what was we considered, and ESA and Airbus considered the most important, which was to do the troubleshooting we've done, which included the 4 cables, so that we could make sure there wasn't they could see whether there was a clocking issue there or whether any of the cables worked, and they did not. So, other questions?
And then there was a question why we don't have any spare on ground.
Spare what?
Spare on orbit for the IORS, for the radio.
All right, well, remember, for everyone, we just flew this recently, so we will have, our intent is to have a second identical radio system in the Russian segment. And in, you know, space on space station is very tight. So we would have to be very careful with our spares on space station. So we have not worked that yet because we're still working on downmassing some of the equipment that we had, and we cannot hook up, you know, the radio, you know, the Ericsson radio at this point. I don't think, because it's stowed for removal. So so hopefully I answered that question. Any other questions?
I think these were the technical questions.
Yeah. I think you all can see we've been extremely busy lately. I've got to give the whole volunteer team a lot of credit. You know, they're trying to work this. We were working in the background, and I'm talking internationally, working in the background, this whole idea of using the spectrum analyzer that the Russians have. You know, we generated lists of questions on trying to utilize it. It's a 10-year-old unit, and you know, and you got to, you know, you're not sure whether the batteries are working or whatever. So we were generating a whole list of questions, and then, you know, the EVAs came up. So I think I've got to give, like I said, the whole international team a lot of credit for what they've done. So Clint was asking about the timetable. For the most, I don't know whether the full-blown EVA schedule is out there, but this is pretty much it. There's a bunch of other tasks. I'd go to ARISS, I mean NASA.gov, but our task is going to be around 1500 UTC. What state are the ARISS contacts scheduled in? I don't fully understand that question, but we're working with NASA and on the for all of the contacts that the US, Canada, Japan, and Europe do, and Roscosmos Energia for the contacts that are being done in Russia. Okay, any other questions? Well, hopefully this has helped you understand better what is going on. I know a lot of you are asking a lot of questions. Like I said, we are recording this, so we will make this available on the ARISS website if you want to listen to it or flip through it. But I'll ask anybody, I'm going to ask if any of our team have anything else to share. Oliver, anything else from your perspective?
No, the only thing is that we are looking forward to the EVA on Saturday, and only for those who are not that familiar with the working on the space station, even if we would have such a measurement equipment available, and that was what Frank just said, these two EVAs really have overwhelmed us a little bit, because we expected normally to have them in 2 to 3 weeks. The situation that we had to react on the spot within some days to plan for the for these test of these cable P1 until P4 has really covered our workload, and we are working as volunteers. That means all the work is not done within working times. These works are done in our free time. That means beside of our business. We are volunteers. We are working like professionals, but please remind, we are volunteers. And therefore, working such a procedure for the crew to operate the FSH-3, for example, the Rodo and Schwarz equipment, the measurement equipment, is not that easy, because if you're looking to a manual and if you're looking to the calibration, and if you have in mind that this is an equipment, for example, which is 10 years old, it is not so quickly done. You have to advise an astronaut what to do, and you have to chase for the material which is available on board, because you need, for example, a representative length of cable that you can measure to have a reference. And all these things covers a lot of work and needs a lot of coordination with a lot of persons. And therefore, it is not that we can give it to the astronaut and say, measure in. And as Lou explained, for example, internally in our discussions, we can even not measure resistance, ohm resistance into the lines, because the cables are looking all open. They are DC coupled, and therefore it doesn't help. Currently, we are really lost, and the last idea that we had is really now to follow on this EVA 73, as it is just shown here on the screen. And this is the next step. If this does not work, then we have to go to the lot of other troubleshooting steps. But this is then part of the next conference that we will provide you.
Okay, that was very good, Oliver. Thank you for saying that, because it's important for people to understand the complexity here of trying to convey this and make it available and ready for astronauts that are doing 300 different experiments at the same time on space station right now. So we have to be very clear as to what we need to accomplish, and some of these things are not easy. Okay. All right. All right. Well, I want to thank everyone for attending today, and like I said, we will make this available, the recording available, in the very near future. Thank